Hey everybody, this is Larry. This is February 13th in the year of 2024, I think. Man, these years just keeps going by. Yeah, let's do a poem that I haven't done yet and we'll call it a night. RNG, give me a easy one. Or give me a reasonable one. Yesterday they did give me an easy one, so it is be careful what you ask for. Alright, today's poem is 2323. Find minimum time to finish all jobs 2. A reasonable amount of, it's a medium, so let's take a look. The upvote downvotes are actually reasonable. I mean, I don't know why, but before that, it was a lot of negative vote problems. Excuse me. Anyway, you're given two zero-index integer wage jobs and workers of equal length, where job sub I is the amount of time needed to complete the ith job, and the workers of j is the amount of times jth worker can work each day. Alright. Each job can be assigned to one worker such that each worker completes exactly one job. So then immediately it sounds like some sort of min matching thing, right? Let me double check. So jobs is the I have to get. Okay, yeah. So I mean, so because okay, let me say it in a cleaner way. Okay, so basically, job sub I is the number of unit of time needed, and worker sub j is how fast they can work. So then you have some like math about jobs over workers, and yeah. So okay, so there are two things, right? And you're minimizing basically the max of jobs over workers, or something, j over w or whatever you want to call it, right? Which I mean, I was honestly normally I was about to say, and it wouldn't be imprecise, but it wouldn't be optimal. Is that I was going to call this an assignment problem, and there are a couple of things that you can do, like the Hungarian algorithm, the what's it called, maximum bipartite matching, which is part of the max flow and stuff like that. So like a couple of things like that, and you can play around with. And there's, of course, if n is small enough, you could do dynamic programming with bit mask and stuff like that. But I believe, and I'm saying this because now, because I don't want to scroll down and look at it first. That is what I do very commonly, and I do advocate for it. But I think in this one, it is actually greedy. Maybe. No, I think it is greedy. And yeah, and kind of in a cheating way. That's why I wanted to, say what I did before scrolling down. Is that saying that n is equal to 10 to the fifth kind of gives credence for that, right? Because like now, well, everything that I said before the greedy is like, max flow is n cube. Hungarian is n to the fourth or something like that, depending on how. I mean, there are some. Anyway, yeah. DP is n times 2 to the n. So like they're all like really, so it kind of gives it away too much. But I mean, I don't know that there's any way to kind of get around it because, but because there is an order of magnitude between those things, and if this is like 10, it's also not that interesting because then you just do a DP, even though there is a greedy solution, right? But seeing that the n is equal to 10 to the fifth kind of gives me this idea this is greedy. The reason why this is greedy is that I had a greedy idea in my head, and that is that and this is an intuitive greedy idea, which is that okay, you sort the jobs, you sort the workers, and then basically you give the slowest worker the least work, right? And here, there is this exchange argument already that you can kind of play around your head, and and we'll do around this. We'll draw it out, and then we'll play around with this, and for the proof, before we implement it. But basically, let's say we have jobs is equal to some A and B, and workers is equal to, let me space it out a little bit, right? C and D, right? And here let's just say we already sorted. I mean, it doesn't, so that means that this is the case, right? Then now we have two ways of solving this, right? We have is it A over C, right? Just want to make sure. So we have now, there are two ways to solve it. So then we have max of A over C, and this is kind of ranked up, I believe, but we'll just keep it like this for now. And B over D, because basically it's the slower job completion, and then you take the one that is the slowest, right? Or max of A over D, and then B over C, right? There's only two ways to assign it because we only have two jobs, two workers. Sorry, I have to cough for a second. Right? And then the question is, okay, let's just say our greedy is, this way, which is the first one, and then now we're D, right? So then, and that's just for now ignoring the rounding up because it doesn't really matter. Because if you have to round up, then yeah. Well, how do we figure this out, right? So then one way to write this is just like doing this comparison, right? And okay. So what happens on A over D here, right? So A over D, assuming that D is greater than C, well, A over D is going to be smaller, right? So let's just say this is smaller, right? What about B over C? Well, I mean, wait, sorry, did I mess this up? Oh, no, D is smaller. So C is smaller. So that means that this is going to be a bigger number, right? So what does that mean? How do we balance it out? So, sorry, I have some idea in my head, but I have to think about this for a second, so sorry. Is it true that this gets dominated? Well, sorry. Yeah. Okay. So because A is the smallest number, and D is the largest number, and it got smaller, but it also means that this number gets dominated by this number, right? Is that clear? I wanted to prove that in my head, but yeah, but because if you kind of, this here is kind of a little bit weird. So now let's compare A over D and B over C, right? So we know that, like I said, A is smaller and D is larger. So this is going to be, no matter what, smaller than B over C. So that means that we can rewrite this as B over C comparison, right? All right. I know that I didn't show it super cleanly. It's a little bit hand wavy, but at home, I hope that, you kind of, if you have trouble with this, just pause and figure it out, right? Like, I think this is okay, manageable, right? And then on the left side, that part is less clear, right? But okay. It's less clear if there's a dominating factor, but okay, let's say A over C and B over C, right? In this case, obviously B over C is going to be bigger because B is bigger than A, right? So then, we can take this out. And then now the second part is B over D D is bigger than C, so B over C is also going to be bigger, right? So that means that B over C is actually, let me undo it. Yeah. So that means that B over C is actually bigger than max of A over C or B over D, if you want to prove. So basically now this is saying that if we had swap, this will always give us a worse answer, assuming no ceiling and rounding and stuff like that. But like, but that means it just means that if you are able to do ceiling and stuff like that, at worst it'll be equal, right? But yeah, and of course this assumes this thing. I guess this thing is assumed because of this greater than. So but yeah. So basically, this is the exchange argument. so this is the exchange argument. Sorry, people kind of pinging me. This is the exchange argument is why you always want A over C and B over D. And this is how you prove that intuition. You have this intuition, and the reason why you can, I know that I only show it for 2 elements, but as a result, now that you showed that for these 2 elements, this is optimal. And then now maybe you could add in a third thingy, right? Let's just say E and F, right? Well, now you could kind of prove it that way with, you know, comparing B, do the exchange argument on this, kind of like in an induction kind of way, and then that's how you build out the entire thing in terms of a proof. So this is that's pretty much it. But yeah, but that's basically the proof, and I know that the proof is a little bit long, and I'm a little bit, to be honest, I have a little bit of a sore throat. That's why I'm coughing a lot and like taking pauses a little bit. But yeah, but basically that's pretty much it. And then, you know, minimum number of days, right? So then days is just, you go to the max of the, for J, where we in set of jobs, workers. Days is you go to max. It should be just J over W, except we rerun and round up. So we do this thing for rounding up. I mean, it would be better if I had the right number of parents. Huh? Oh no, I think I had an extra one, that's why. Okay. Okay. Oh, I guess you don't have to round up. I misunderstood this one. But I mean, it doesn't matter. The proof is still the same. It just means that this is now a float, so we don't have to worry about this. For some... Why would you let... okay. The phrasing is a little bit... Oh, wait, no. I did it with a float. Oh. No, okay. So I interpreted it right, but somehow I did it that way. It was just a typo, I guess. Because I don't know what happened there. I think I was just showing it. But, okay, yeah. Yeah, and that's pretty much it. I know that I get a lot of questions about proofs and stuff like that. Like people ask me a lot about greedy and how to prove it. This is one way to do it, so hopefully this is a way, you know, just like a video to show you how. And of course this is going to be n log n for both of these. Technically it's O of n space because the sorting kind of, you know, changes the input, so you should make a copy of it instead of changing the input. But yeah, however you want to say it is fine, right? But yeah, n log n time though. And that's pretty much it. That's what I have with this one. Let me know what you think. I mean, this can be, I think the thing with this problem is that it is very easy to come up with the intuition, but you know, I wanted to take my time on this particular problem to do the proofs because I think I get that a lot. And yeah, okay, for this one, your intuition is correct, but how do you prove something that's harder? Well, I mean, you have to build a strong foundations of things that you understand, and it means sometimes proving, quote unquote, proving, or sorry, not quote on the proving, but proving, quote unquote, the obvious stuff, right? So yeah, that's pretty much it. That's all I have for this one. Let me know what you think. And yeah, stay good, stay healthy, to good mental health. Happy Valentine's Day, everybody. I'll see y'all later and take care. Bye-bye.